In this video, we are going to demonstrate advanced policy-based routing, also known as application-based routing with midstream support. So again, this is our little setup. We have a CSO that has provisioned or instantiated a VSRX on a spoke device. We are going to use NFX 250 as a hosting device. We have two links, some IP networks in between the spoke and the hub device, and we are going to send traffic from client side, from left side to the right. So we are going to observe two links, 002 and 003. We have tunnels established over those two links, and we are going to label these two links, one as MPLS and the other as Internet. So these designations will become important once we start pushing APBR policy from CSO onto VSRX. So basically, application-based routing in its essence is ability to route traffic based on the application. So we will see how this can be achieved and also what happens with applications that are cacheable and non-cacheable. So let me show you the next diagram. So basically, this is what we are going to demonstrate. For use cases, we are going to look at cacheable and non-cacheable applications. As a cacheable application, we will be sending a SSH, non-cacheable YouTube. We will be applying APBR, and then we will observe what happens when midstream support is off and midstream support is on. There is a lot of confusion out there in the field about midstream. So let's try through this demo to clarify what midstream is and how it can help us to achieve APBR in cases where we have cacheable and non-cacheable applications. So let's get started. Let's observe first the case, which we are going to call case 0, where APBR is not applied. So case 0, no APBR. What we are going to do, we are going to send one session of SSH traffic from a client side and see which of these two links the traffic will take by default when no APBR is applied. So we are here under admin portal looking at application SLA profiles. We see that we didn't define any SLA profile, and consequently there are no SDWAN policies. So this is the case without APBR. So we have our NFX device. It's the same device, and we have our client device, which we'll call it's a Linux device basically. So let's start sending some file, which will initiate an SSH session, and we are going to observe which of these two WAN links traffic is going to take. So the links of interest are again 002 and 003. So let's see which one traffic is going to take. By default, when APBR is not applied, and we see that the traffic is taking gigabit Ethernet 002. So let's now observe case 1, where we are going to apply APBR, and we are going to nail the traffic onto gigabit Ethernet 003. Okay, let's observe the first case, which is APBR applied, midstream support switched off, and application that we are going to look at is SSH, which is a cacheable application. So in our diagram for APBR midstream support, we are here in this first quadrant where we have midstream support switched off, application po advanced policy-based routing applied, and we are looking at a cacheable application, which is in our case SSH. Also, what is important here is that we designate between a first session and subsequent sessions. We are going to see the reason for this. Okay, back to our screen. So let's quickly revise without, currently I don't have APBR applied. So let's just repeat what we had from the previous example. We see without APBR, the traffic is taking Gigabit Ethernet 002 link. That is the link that we called MPLS. So let's nail this application, SSH application. Let's nail it down to use Gigabit Ethernet 003 that we call Internet link. Okay, so let's go back to the admin portal. Currently, we don't have application SLA profile defined, and obviously no SDWAN policy. So we are going to apply a super simple, define actually a super simple SLA profile called, let's call it like Internet, and we want Gigabit Ethernet 003. In our case, that is our Internet link. So this is a static policy, super simple. And let's apply SDWAN policy that has this SLA profile defined. So device of interest is NFX17. It's SSH traffic that we are looking at. We have just defined SLA profile, and let's call this SSH Internet. Save. And we are going now to deploy this onto our VSRX device VM that is spawned on NFX. So while this deployment is in progress, let's quickly see what we are going to do. So basically, we are going to nail with this APBR profile, we are going to nail SSH onto Gigabit Ethernet 003. So let's get back, see where this is. Yeah, so deployment still is in progress and deployment is successful. So now we have APBR applied. But because we have sent this session before, so this means that, and this is a cacheable application, SSH. So what happens is this is not anymore our first session. So how do I know it's not the first session? Because if I look at application system cache on this VSRX device, I will see that this device has knowledge of our SSH session because we just sent before to demonstrate when APBR was not applied. So let's get rid of, let's clear application system cache. Okay, let's see what we have now. Obviously, there is nothing there. It's completely clean. Let's also clear security flow sessions. Let's clear all the sessions. So now this device basically is ready, has no knowledge of previous sessions. It's completely clean, and we are going to send traffic. So But this time, unlike previous example, we have APBR policy applied. And we would now expect traffic to take gigabit Ethernet 003 link. Uh, one more thing, actually, which is extremely important. Currently, I need to make sure that I have switched off um, midstream support. So our first case one is with midstream support off. So we are going to observe what happens with the first session of SSH cacheable SSH application with APBR applied and midstream support off. So the command you can read about this command, this is the command that switches on and off midstream support. So let me just quickly set this to 0. If I set this to 0, then mid-switch support is disabled. Okay, our device is now completely ready. We have cleared application system cache, no security flows so far, and maximum route change is set to 0. So that means there is no midstream support. Only APBR is applied. So let's start sending traffic, and we would expect that traffic, because APBR is applied, take link 003. So let's see what happens. And we see that this session actually is not taking gigabit Ethernet 003, it's still taking gigabit Ethernet 002. So let's go back to our example. So cacheable application, midstream support off, first session, APBR is applied, but it doesn't take effect. So it cannot take effect. Why? Because without midstream support, routing already happened. So there was no time to recognize this application and to apply APBR. So for first session, APBR is not applied. And we clearly see that this first session is taking gigabit Ethernet 002, which is default route that we saw before. So let me now stop this session. Let's check system cache. We see that the SSH session is here. Here it is. So system actually stored details about this session in application system cache. It will expire after 1 hour, but it's still there. So let's clear interface statistics all to help us to clear this clutter. And we are going now to send again, initiate another session, which is in this case going to be second session. But the difference from before is that first session made basically this device to know about this application. So application has been stored in application system cache, and let's do the first session and see which link now the second session is going to take. And the second session takes link gigabit Ethernet 003. So the second, third, and any subsequent session will take the link that we specified through the APBR. So if I stop this here, start again. This is a third session. Third session is taking again 003. Fourth session again is taking 003. Let me quickly show the statistics. And it says here route changed on cache hits 3. So let's try this again and see what happens, whether this number, well, yep, it went go by 1. Another one, it went up by 1. So we see that system is changing the link the traffic would take by default, which is 002, is changing to 003 based on APBR and based on the fact that there is a knowledge about this session in application system cache. Now, just for the sake to confirm that our observation is correct, let's clear application system cache one more time. There is nothing in the cache, and if we are correct, that means that we are again, we just have reset all the knowledge on this session to 0. There is no knowledge. Application system cache is empty. If we are correct, traffic now is gonna take again the default link, because APBR in this case cannot act upon this session because it's gonna be again first session. So let's clear also the statistics. Let's start the session. And we see that by default, traffic is taking 002, which means APBR in this case cannot act. So first session, APBR no, second, third, and any subsequent session, APBR yes, in which case, in case of cacheable applications, with midstream support switched off. Okay, let's do case number 2. APBR deployed, midstream support this time switched on. Again, cacheable application, SSH, that we are going to observe. So we are now in our second quadrant, where we have midstream support on. We are looking at the cacheable application. As an example, we will be observing SSH traffic. And in this case, we are going to see that even for the first session, APBR will be able to kick in with midstream support on. So it doesn't matter anymore whether it's first or second or any other session, APBR will be able to switch traffic to the correct link according to our SLA policy because of the midstream support that is now on. Okay, we are back at our screen. Let's clear the statistics first. Let's make sure that midstream support is on. By changing this number from 0 to any other number, by default it is 5, we are automatically switching on midstream support. So let me commit this. Let's start again like before. Let's clear the system cache. We want first session to see what happens with the first session. Okay, let's clear statistics as well and clear. Okay, we now see that there is no previous session left in the application system cache. Application system cache is clear. So now let's start sending the traffic. This is going now to be the first session. And what we want to observe here is the traffic automatically takes the path that we specify through the SLA policy. So let's quickly revisit. So we have SDWAN policy. We want traffic, SSH traffic, to take internet path, internet link. Internet link in our case is gigabit Ethernet 003. And we see that application system cache is empty. So this is going to be our first session. So let's see what happens. And traffic immediately takes gigabit Ethernet 003. Let's see the application statistics. And we see that route is changed midstream. So this is the difference from the previous observation that we had. So let's do this one more time. So again, stop the traffic. Let's clear security advanced policy-based routing. Actually, let's not clear it, but what we are going to clear is system cache. So application system cache is empty. Let's start the traffic again. This is again now the first session. And what we expect to see that this number goes up by 1, even for the first session. And here you go, route changed midstream second time. So this concludes our second case, which is even for the first session with midstream support on and the cacheable application, traffic can take the right link. Let us now observe a more complex example. We are going to look at a non-cacheable application, namely YouTube. We are going to apply APBR, but in case number 3, midstream support will be off. So let's see where we are. We are now in quadrant number 3, case 3. We are looking at application of APBR with midstream support switched off. And as an example, we will be looking at YouTube as a non-cacheable application. Before we continue, let's clarify some things here. So basically, for cacheable applications, I was talking about first, second, third session, and so on. But for non-cacheable application, it's important that we somehow have this feeling that every session is always a first session. Why? Because there is no memory in the system. The application cannot be cached. So that means every new session will be treated exactly from scratch. So there is no previous memory of that session. So system has to recognize the application, and once application is recognized, then APBR can be applied. So although I put in these two quadrants, first, second, and third session, just to make them equal with cacheable example, for case number 3 and case number 4, actually every session is always the first session. So once we know that, let's go to our screen, and very quickly we are going now to do an example where we don't have APBR for YouTube traffic applied. So from our previous examples, we have SDWAN policy that only acts upon SSH traffic with application SLA that we put for our previous example. So there is nothing here that acts upon YouTube traffic. So I'm going to fire off basically a number of YouTube sessions. And also while that is happening, it takes a little bit of time for system to come up. Let me show you what I'm going to match on. I'm going to match here on Junos YouTube as a dynamic application. And also because we have two links, one is gigabit Ethernet 002 and the other is gigabit Ethernet 003. So this tunnel is our internet link, gigabit Ethernet 003. And here I'm going to match basically on GRE tunnel 4001, which is our MPLS link. So that's what I'm going to match here. The traffic has just started, and we see that sessions basically are pretty much taking, I would say, taking both links. So let's check. So we have some YouTube sessions going via 4001, and some sessions are taking 4003. So basically, there is some kind of ECMP distribution between the two links. Again, a number of sessions are being sent. So this is a very realistic example. And without APBR, as we expect, nothing happens. Both links are being used in this case. So let's stop this test, and then let's go and apply a SLA profile. We're going to use a simple profile where we are going to say to choose for MPLS link. So we are saying move all YouTube sessions onto the MPLS link. For path preference, we are putting MPLS, and here we are just giving a simple name. We are not changing anything else. So once we are happy with our SLA profile, let's apply that profile via the policy. So again, this time we are going to act upon a YouTube traffic. SLA will be MPLS, and let's call this YouTube MPLS. Save and deploy. So deployment currently is in progress. While this is happening, we can also prepare our traffic generator to start sending the sessions. So actually, one more thing which is very important now. before we start sending anything. So first, let's clear all flows that we had before. So yeah, we cleared the flows. Because we are currently deployment is successful, so APBR has been deployed. Because we are observing the case where midstream support is off, case number 3, let's make sure that um, there is no basically midstream support enabled. So I'm gonna disable midstream support by putting 0 here. Okay, that's good. And statistics, let's clear and see what policy-based routing. Oh, I need to leave edit mode. Okay, show security, advanced policy-based statistics. They're all 0. So let's now start traffic when we have APBR applied and see what happens. So again, while we're waiting for test generator to get loaded, we are observing case number 3, midstream support off, non-cacheable application, YouTube. So let's see what happens here. Okay, we have cleared all the flows and statistics is also, I can actually clear interface statistics all. So in this case, although APBR is applied, because there is no midstream support, we should expect to see exactly the same thing that was happening before when APBR was not applied. Basically, all these YouTube sessions are using both links. Yeah, they are using both links. So basically, our intent is not successful. Oops. Let's see the statistics. Uh, there is nothing on cache. Obviously, cache cannot exist here because it's YouTube, it's non-cacheable application. Route change midstream, we disabled midstream, so midstream cannot kick in. So this concludes case number 3. YouTube sessions are taking almost equally both links. And we have come to our last example, which is case number 4, which is APBR deployed, midstream support is on. Again, we are observing non-cacheable applications. As an example, we are looking at YouTube. So again, we are in quadrant number 4. We have APBR deployed, midstream support is on, and non-cacheable application, example of which is YouTube. So let's see what happens in this case. Again, what I said before, for non-cacheable applications, there is no memory about previous sessions. So the notion of first, second, and third, and any subsequent session is a little bit artificial. I just put it to make it comparable with the cacheable examples. But in this case, every session is always a first session. Okay, we are back at our screen. I'm going to stop the test that previously we ran for case number 3. This time, we are going to enable midstream support. Let me just show you that APBR is applied, so nothing changes from the previous session apart that we are going to enable midstream support. So from 0, I'm changing this to some number. By default, it's 5, I think. Commit. That's fine. Let's clear previous sessions. So let's do this actually. We are going to, let's refresh this like every 5 seconds. And refresh. And basically I forgot to put the important bit here. So let's count this and then okay, that's better. And count here. And refresh. And also let's clear the statistics. Exit, show security. So clear security, advanced policy-based routing statistics. Okay, and let's refresh this every second. So in this case, once we start the traffic, we will expect that we see that route gets changed midstream. So that is why I'm doing this, and we are going to observe on which link these sessions will end up. So by our SLA policy that we have defined, we told that we want to use MPLS link, meaning we want to use gigabit Ethernet 002. So we expect traffic to be here. So let's fire off the sessions and see what happens. So again, while this is starting, we are in quadrant number 4. We are observing non-cacheable YouTube application with midstream support on and APBR applied. It takes a little bit of time for traffic generator to start generating these sessions. Okay, we see that sessions are being established, and let's go back to our screen and see what happens. Okay, here we see that our MPLS link is already taking the traffic. Look what's happening here. Routes are getting changed midstream. Internet link 0 sessions. So let's check what's the rate of the traffic. So we are sending around 1300, around 1400 packets. So 1400 packets are entering the system, and pretty much we see that all traffic has converged onto the MPLS link. So see how route changed midstream here. So all the sessions are taking MPLS path. None of the sessions are on the internet link. So this concludes our example. And in case number 4, we see that APBR is successful even with the non-cacheable applications like YouTube.